He was good. Oops. All right. All right. Well, thanks for to the organizers for inviting me here. Today we're going to go through what I'm calling a bird's eye view of microservices testing. This kind of a little bit of a teaser to a workshop that I give on microservices and how to validate microservices from kind of a full stack perspective. So for folks who don't know me, my name is Tariq King. I'm the chief scientist over at test.ai. And I kind of spent my career along the software testing, software quality path. First started in Florida Tech, where I was a student. There we had two great minds in testing, James Whitaker and Kem Kainer. Was fortunate enough to do courses with those guys and uh, even present alongside them in different capacities. And then I went on to do my master's and PhD at Florida International University. So I kind of started in quality in the academic realm, did an internship at IBM Research Lab in China, and then went on to be a professor. So I spent about 3 years at North Dakota State University teaching software testing courses, formal methods, uh, software construction, just anything to do with how to build systems properly or to test them. And then I transitioned into the software industry, moved to a company called Ultimate Software, where I was there for 8 years as a test architect, and then eventually went into becoming a manager, director, and then the head of quality. And a lot of the work that you see here around the microservices testing happened due to my experiences at Ultimate Software, and I'll share a little bit about that. Where we were going through this transition, and I found a lot of folks are going through transition where they're going from a monolithic system into the world of microservices, and then there's not a lot of information about testing, and that's kind of what sparked me to create a workshop around it. So we'll get into that. All right, in terms of the agenda of this talk, we're going to just go through microservices, what they are, some characteristics, and why microservices are even a thing. Then get into what is the crux of it, which is microservices testing and testability, what I call the good, the bad, and the reality of microservices testing. And then give you a bird's eye view of the workshop, get into the agenda and go through some of the content and even deliver some of the content as much as I can with the limited time. And then we'll wrap up and then open up for questions. All right, so microservices, right? When I first heard this, I was a little taken aback. Microservices, what's going on here? Is this just services-oriented architecture? Is it another name? What are these microservices, right? In terms of a formal definition, we're talking about a functional decomposition of the system into these small, independently deployable services, right? And when we talk about functional decomposition, we're really talking about this vertical slicing of the system, right? So we're talking about decomposing the system differently than the traditional horizontal layers that we're accustomed to, probably, presentation, application logic, data access. Now, instead, we're going vertically and are really putting multiple pieces of related functionality independent of the layer of the application that it might lie into a service, right? And so maybe all of the transaction management and all the logic for that, as well as the data, is stored in a particular service. Micro, as the name suggests, refers to something being small, but there's not really a universal definition of what it means to be small in the microservices world. So some people look at the domain and try to make it as small as possible, but as big as necessary to model and represent the domain. Small for other folks might mean, it can be managed by a small team of, 5 to 6 people. And the last part of the definition of being independently deployable is really talking about taking each of those services and being able to host them on their own computational node, right? And this is very different from a monolithic system on the right-hand side, where all of the processes are on the same node. And obviously there's pros and cons to that. On one side, On the left, you see all the communication overhead that has to probably go into something that is distributed like this, versus something on the right where there's still communication, but it's on one node, and that is a lot quicker. But then on the downside, if the system goes down, on the right, everything is down, right? Whereas on the left, you have a lot more resiliency that can be built into the system. So this whole idea of microservices really represents what is the shift towards just bringing solid and design for testability principles into the service level, right? So we've all heard and seen that, okay, you should have a single responsibility for your components. They shouldn't do more than one thing, or they should be encapsulated to hide away any kind of information so that the clients are forced to use the interface, or they need to be observable, clustered, just have them be technology agnostic. There's a lot of these principles where, having them at the service level is great and adds to the software engineering, design and extensibility, and different properties. All right, so in terms of motivation, the first thing to know is this aligns very well with DevOps practices. And so you'll probably always hear microservices being used alongside with DevOps, which is development and operations working together, which is a shared ownership of the software development and delivery aspects of engineering. And so, your team basically can own your service, the service or a set of microservices from the time that they're, thought of to the time that they retire. So you're coding it, testing it, deploying it, maintaining it. DevOps is a lot about automation, and microservices enables quite a bit, right? So you're talking about being able to make changes because they're small. You can make those rapidly and frequently and ship that code out. It kind of fits well with DevOps. There's less risk of downtime when you think about the system now. When things being offline and online, now you can take down parts and have upgrades happen, or you can fail and roll back, or even fix forward. So this idea of microservices is right in alignment with DevOps, as well as agile processes, right? So agile is about slicing, your workload into these, small discrete pieces and delivering them within a sprint of 1 to 2 weeks. Well, again, being small body of code, easier to change, less fragile, you can now deliver those things incrementally within agile. All right, so now that we kind of have an understanding or on the same page as to what microservices are in terms of the definition and the motivation behind them, I'll tell a little bit about how all of this came to be. I mean, when we were first thinking about going into microservices, we had the architecture team looking at, the future of what we should do, and microservices was this next big thing. And that frequently happens in organizations where architectural group or some other group that's looking forward is saying, hey, we should be going this direction. And what I found was that, the testers, and this is where I kind of use Chicken Little to represent the testers in the organization started to panic of sorts, because we started to think about microservices. How many microservices have we thought about how we test these things? Now we introduce all of this networking and all this overhead into our development process. What is happening with testing? And for them, it honestly started to feel like the sky was falling, right? And the end was over. It's now, no more quality because we can't keep pace with whatever is happening from a development standpoint. And again, I came from a different world, right? I came from the academic world and had an opportunity to study a lot of the foundations of software testing. And that's not people's usual path. And what I started to notice was that, well, folks around me would get very scared and intimidated about change. I never really had that problem. I had a sense of confidence knowing that, if we look at our foundational principles and practices and our experience over the years building and testing software, that we just need to look at this new paradigm and be able to dissect it and see well, what is really good about it? What is bad, or something that we need to make sure that we look at for opportunities to improve? But that, having that foundation will allow us to test these things, and we just don't need to worry. And if there's something that we don't know, we'll learn it along the way, and hopefully we can contribute to the body of knowledge. And so that's exactly how this course came about. We went through that transition for about 3 years, 3 to 4 years. And as we went through it, we were learning things about testing and building on them. And then we had the thought to come together and create a course to really be able to share those things and have it be a hands-on course that had a practical component. So you'll see later some of the practical things that we do in the course in terms of hands-on and the open source repository that we have out there for this stuff. But it's really an idea around going through the full stack of this new particular architecture and having references to it. All right, so microservices testability, and testability being the degree to which something can be validated or checked for quality, or the way where you can write requirements that are testable against it and that sort of stuff. And on the good side, and there's a lot of upside for microservices, right? Where you have now a situation where all of these relationships that components have with each other are explicit, and they might even be owned by different teams. We saw the diagram where each of the services, you saw all the lines, and it kind of looked crazy, but at least you could see it. Like on the right with the monolith, and of course there's lines that of communication, but the reason that I even illustrate it without the lines is because normally people just see the monolith, they go in and they change the software, they don't have any idea about the dependency graph, they go and change something here and then it breaks something else, right? That is the world of the monolith. And at least with microservices, you can no longer just ignore those dependencies and have bad things happen or creep in. Focusing on single responsibilities also allows us to do more focused testing and debugging. That's always a good thing. Monitoring improves observability. So you'll see again with the DevOps world, these services are being monitored constantly. Their health checks and things that allow us to see where issues could possibly occur, or at least track them to see if there's any relationship between any kind of bugs and the performance of the system or the performance of a particular service or different events that might be happening at the time that something is going on. Clustering, which is the fact that you have multiple microservices that can be spun up together, right? So you can have more than one instance of the same microservice. That also allows us, to do better testing and easier testing. You'll see in the course, we use Docker to allow us to just be a little bit more efficient on testing. And the way that that's possible is just being able to spin up services on demand in their own containers, connect them in, duplicate if we need to. And if we need to reproduce a test, we can use the same type of environment, those same containers that is, kind of being used in production as well. And it just makes things a lot easier. There's also a lot of isolation once you start talking about these independently deployable services. That isolation also allows for quicker test cycles. And last but not least, even if there is gaps in what is needed to be done for microservices, there's also an opportunity to reuse the things that we've learned along the way from testing APIs and other things, testing classes, and apply that to microservices. So we can always apply that over or translate that, and you'll see some of that testing applies here in terms of some of the guidelines. And then there's also an opportunity to create new knowledge and new tools, which you'll also see as part of this course. All right, so on the bad side, there's a natural fear associated with a new paradigm or any kind of transition. It's unfamiliar, there's open questions, things are changing. So that's definitely difficult to deal with. The complexity of the monolithic application now shifts into the network. And so now you have all this added complexity And you can try to move it around, right? You can move it from this service to that service, but the complexity is still there. And now you add networking, messaging, and you know, with microservices, they tend to be agnostic or technology agnostic. So you can use different technologies to implement service, different databases, different programming languages, all in the same system. And that can create issues, right? Issues with team members not being able to be fungible and go from one team to another, or just technological issues because you're now using so many different frameworks and the points of failure for those bugs is all over the place. Uh, Obviously, there's now an added layer of communication. So inter-service calls over the network have a higher cost than the in-process calls that happen within a monolithic system. So you have to watch performance. You can also have this explosion into the number of tools and technologies that have to be maintained. And if a microservices actually gets too small, you have this um, nano service, or this kind of nano service pattern that I like to call it, right? Where the overhead uh, of dealing with such small, fine-grained things actually outweighs the benefits or the utility of having them around. And so you have to be careful to watch for that, right? One, having a service have a single responsibility is different from having a single function. I remember having discussions with some engineers about, oh yeah, a class should only do one thing and that means it should only have one method. That's not the level of abstraction that we're talking about. One thing could consist of many related operations, but one goal, one objective is the idea there. And then sometimes you get into this once you start getting to this, test engineering and technical testing. Folks like to do mocking to narrow down and isolate, but if you do too much of that mocking, you can have very unrealistic tests. I've seen it before in organizations where they're doing all this mocking and they're really not testing anything meaningful that can find any kind of issues that will actually happen in production. So all these small unit or service level tests all pass just fine, but the integrated system still doesn't work, right? So another kind of caution. And so I guess all of this is just to say that the reality of microservices testing is really that there's good and there's bad, and you're not going to get rid of that fact. You have to work around it. But the whole idea is that you try to find opportunities where the things that you may not feel are in your favor are manageable, and that testing is all about risk and managing risk, and so you have to be able to step into that with that mindset. All right, and I forgot to mention, but if we can have a Q&A at the end, or if you really have questions or points of clarification, please feel free to interrupt. So now we're going to kind of shift into what the full workshop looks like, right? As opposed to just talking through some of the content. But with this workshop, what we have is obviously the introduction to microservices. I just kind of gave you some of that, not all of it. There's a lot more information around just services, the different components of a microservice, the structure, how they behave, how they communicate, talk about REST and that sort of stuff as well. And in that beginning portion, I introduced and give a first look at the project, which we'll get to in a second as well. And I do all that before I actually step into what I just talked through, which was the testability stuff that we just did. And then for the rest of the entire course, like the rest of the workshop, we're actually going through each level of the test pyramid for microservices testing, starting at the unit level. And we'll say what we mean by unit there, because there's two different views of units. And then getting into what is integration testing of sorts, which is the beginning of it, which is contract testing. It's a very specialized form of integration testing, talking about service readiness, and then getting into what is true integration testing across domains. And then I leave off by talking a little bit about system testing, even though testing the system, a lot of things don't necessarily change, but some things are a little bit different. So it's kind of what the pyramid looks like, where, again, I don't really go through a lot on system testing. I kind of just mentioned it. So like the top of our pyramid here for the purpose of microservices is the system integration level. and then your contract level. And then there's treating the microservice as a unit, which I refer to as service isolation testing. And then your traditional testing that you would have where you have either classes or some sort of functions or procedures, you have unit and integration testing at that level. Now, one thing I like to do, and this course is really for a beginner, right? You don't really have to have any prior knowledge of even API testing to take the course, or definitely not have to have any knowledge of microservices. But so what I like to do is start off by showing folks just what a REST API is all about and how to test it using Postman. So one of the things that I use there is this site called RecRes. I don't know if you guys have ever seen this. There's a pretty cool site that has a hosted REST API that is just ready for you to use, right? And you can test your front end against this API. So there's lots of different functions available. And then there's obviously Postman, right? So what I do in the beginning is I just kind of walk people through using Postman to invoke an API and then looking at what are the results, right? So that people get a feel for this is really all API testing is all about, right? It's about invoking some URI and inspecting what are the return results in the headers or the body of the payload. And so I kind of let people try that themselves and play around with that for a little bit. And then I dive straight into the actual project. And as I said, the project is actually available on GitHub, free for everyone. And you'll see that a lot of the stuff that is embedded in the slides is, in the documentation, the README, a lot of the technologies and the architectural documents, and even some other behavioral documents. And then it kind of starts to step into all the requirements and how to run the project. So everything is actually just there. And what I do throughout the course is actually step through each of the sections for each of the types of microservices testing. There's some guides and there's some exercises and that sort of stuff. So we'll walk through this as part of what we're doing now, but just wanted to show you guys that is indeed out there, and that would be part of the course experience. So what we've done for the project, we've taken something that folks should know about, right? At least, and most people have a bank account. So we took the banking domain, where you have checking accounts, saving accounts, you have transactions that are processed, and we built a reference application, which is part of that repository. And we built it using a cross-section of microservices and microservice architectural related patterns. So, for example, there's two domains, and we'll kind of still try to keep this pretty brief. There's two domains, one for people, which has to do with your customers and all their details, and then another domain around accounts, right? And you'll see that there's a gateway, there's a discovery service, there's the microservices that really will be more internal to your application. There's databases connected to that. There's lightweight protocols like gRCP, and there's even an event store because we get into, and you'll see it, we get into eventing and CQRS. So you'll see that there's some command and some query services. If this doesn't make sense yet, we'll talk about it. But I normally like to show people this diagram early when they don't even understand much of it yet. And then we revisit it in the end after we've gone through everything within the course so that you kind of understand what is going on. And there's some very cool things that we do here to help with what is that full stack, right? So we use in-memory databases so we can do some mocking using an in-memory database and mock out some of these stores here and different things. So for the full tech stack, clearly, like I mentioned, from the deployment and runtime perspective, we use Docker, we use Express Gateway for our API gateway. The framework that we use is Micronaut, and the programming language is everything is done in Java. There's MongoDB, there's gRCP for a lightweight communication protocol, similar to HTTP, but it's better for internal communication between microservices. Our discovery service, and everything's implemented in console. And so you can do your health checks using that. You'll see that. We use WireMock for mocking at the service level. We use Mockito for mocking at the class level. So there's tons of technology. We use Pack for contract testing, tons of technologies that, and again, this is, to me, this is part of being realistic about microservices testing is that uh, doesn't matter which stack you use, that these types of things are going to be part of your world. So if you're using eventing, there's some sort of event server or eventing mechanisms, right? And for that, Axon represents that. So the course is less about the specific technologies. Of course, we have to use something, but the whole idea is that you have a holistic view of all the different pieces of this whole architectural reference architecture and whole paradigm, I guess. All right, so to kick it off, we get through to just looking at Docker and containers, and the whole idea here is that containers, the idea comes from the shipping industry where everything is in a container, and containers are lightweight and efficient to transport. Everyone is probably familiar with Docker by now, but the whole idea is that the code, the runtime, the tools, the libraries, everything is in that container, and so it becomes easy to pass it around. And so for the project, the first thing that we do is spin up the microservices, build the project, spin up all the services, and show people how to view the containers that are currently running. We actually pause one of the containers and then go to console, which is our health checks to show that the whole microservice went down. And so you'll kind of get that experience, and then we take you to the to see the services and how you do the kind of health checks through the discovery service. So that's pretty cool to just start off and get people familiar with how these things work. Again, Docker is like a life-saving thing here because this would be a lot harder to do. One of the reasons that we use Micronaut instead of using things like Spring Boot for the microservices framework is because Micronaut is pretty fast, right? And pretty, in terms of overhead, we had a lot of challenges with when we were using Spring Boot at first, with how long it would take services to come up, the footprint of Java and all that stuff. So if you haven't heard about Micronaut, please check it out. But we use that to kind of make this tutorial experience a lot better. All right, so after you spin up the services, we kind of get into each level of the testing pyramid. We start at the unit level where we talk about class testing. And even though this course is on microservices, you got to still remember that it's still built up of other components or smaller components. So we talk a little bit about some of the guidelines for writing good unit tests and writing good tests at that level. Of course, the unit testing really doesn't necessarily change, in terms of principles and even practices. And some of the implementation looks different because of what you might be testing, right? Resources or domain objects or repositories. But basically what we do is that we focus our testing here, right? Which means that our unit tests actually mock out everything that you see grayed out here is actually mocked out using Mockito or using any other aspects of themes that we can build. And so we start here, right, at the most basic level where you should have tests around these things and actually use the anatomy of the microservice to kind of really even give you a visual of how that looks. And then we get into integration level stuff, right? Which starts to look like, okay, it's not really integration of just the classes alone, but now we can look at the entire microservice, right? So the microservice now becomes our unit where everything within this yellow box here becomes part of what we're testing. But we mock anything as well as the MongoDB that's part of this microservice. But we mock any external dependencies like the event streams or other services that might get called, right? So we use WireMock to do that. And we also use Redis if there's some sort of external data store. Remember, all this is internal to the microservice at this point. And so we we leverage that. Right, and then we expand out where now we are looking at, having event-driven aspects of our microservice, right? So you have to think, okay, there's a whole bunch of stuff that we can do and need to target. Um, but eventing is a little bit different from the traditional kind of invoke a service, right? So we actually look at Axon and how to start to do testing around that in a bit. But before we do that, we just show folks how to run the same test that you have, right? So if you go back to this, you see that, or you can imagine that these tests, even though they use mocks, could be rerun on a different configuration, right? And that's where the power of Docker also comes in, where we have different configurations and different flags within our reference code to allow people to run the same test on a different configuration, so you can kind of build out your testing and isolate things. So for the eventing, we kind of get into the whole idea of event sourcing and CQRS, which is command query responsibility segregation. Again, these are two patterns that, even though they're strictly not necessarily microservices, they're very related to microservices. And so you'll normally hear people talking about event sourcing and using that, and as well as the CQRS pattern and applying it to different points in the architecture. And so what we do then is, go through how to test these event-driven systems, right? So your test, for example, looks a little bit different than your typical, setup and execute test and then assert. Here you're talking about events. So you're actually creating commands, sending those commands to be processed, and then checking to see if there are events that get emitted. Like here, given that you do this create command, when you actually execute the command, then you want to expect no events for this particular thing, right? So depending on what it is, you might expect a set of events to come back or not. So we go through how to test event sourcing using the Axon framework. All right, we also get into contract testing using PACT. And again, this is something that when you think about microservices, it sounds like contract testing is a new thing. I actually studied contract testing back in school before there were even microservices. The idea of having a contract for a component and building your testing around it is not a new idea. And so a lot of the fundamental work on contract testing and a lot of the principles behind contract testing are embedded in the course. And we also talk about defensive design as part of it, right? One is where you have this mutual agreement between the sender and the receiver. And so that can make some types of testing actually simpler at certain levels, but then it complicates testing in other areas. And then the whole idea of design by defensive design is that you don't trust, and normally you're doing a lot more negative testing for defensive designs as well. All right, so for that we use PACT and we get into the PACT framework. You can check that out. And the whole idea here is that we want to show people how to actually implement what is consumer-driven contracts using PACT. And so with these, again, it's kind of a form of integration testing between services, but it's in a very scaled down environment where only certain aspects of the service are available. And using the contracts and building out the contracts allows us to run those tests relatively quickly. And so you can test the contract between the account transaction service and the account query service, right? And you can look at that. I should have like at least a visual here of PACT. And so we show folks how to spin up the environment, start the PACT broker, how to generate the packs and then run them and then view the results and then spin down everything. And the cool thing about this, as I said, is that we actually do something that's a little bit different in that normally it might end there if someone is showing you PACT, but because we have fully integrated it into our reference architecture, we show how to not only generate the packs, but how to have packs that actually we actually generate the packs themselves using a class and show how you do the mock repositories for the customer data and the different environment configurations. And the cool thing is that there's a guide. So after we kind of show it, you kind of walk through and there's a guide that you can follow. So here's the guide again on the GitHub site where you can see an example of a pack contract, how we write the fixtures. You have your example fixture, and then and the full code behind it, and then how you can actually run all that stuff, and then you get to try it yourself, right? So there's an exercise embedded in the project where you get to then apply what's in the guide and extend the code and run it. So again, pretty much for a self-paced learning that you could do it on your own. So the whole idea there is that even after you do the tutorial, you have all these resources where you can go and really digest all of the information and practice it, right? So, all right, so the next level of the pyramid after we get through the pack testing is really service integration. And this is something that folks, you don't hear them talking about much in the microservices world. They talk about contract testing a lot and they end there when it comes to service integration. And I just remember when we had we had a consultant that came in to help us with the transition to microservices. They really didn't know much about testing. And we were talking and they were saying, oh yeah, you don't need to do a lot of integration testing. And then I remember a year or two later, and I disagreed with them at the point in time, and all of the leadership team in our quality organization also said like there's just no way. And I just remember a year or two in it, most of the issues happening around integration, and later him saying, yeah, I was totally wrong about the integration parts. And so you probably might not find much information about doing integration testing outside of the contract testing that you see. But you have to remember that there's a bigger context, right? There's an interbounded context where things do talk to each other. And so what we've done here is actually applied some other techniques from other areas of testing to microservices. So there's three major techniques. I'll go through one of them here as an example for this talk, but we go through each of these in detail. But there's using test ordering integration to try to reduce the amount of work that you have to do to create mocks and stand up different mock services. Then there's the idea of pairwise integration. If you're familiar with pairwise testing, it's kind of applying that principle to the different pairs of services that need to be exercised. And then the last one, which is my personal favorite, is neighborhood integration, which we'll actually walk through that. Because when I gave this tutorial in person live, probably in 2019, I had some folks in Netflix come up to me afterwards and tell me that they really enjoyed this portion of it and they were going to go back to their company and implement it. And I was like, wow, this is really cool because this is Netflix. Like these are the folks where a lot of this microservices stuff started, but they really didn't have many techniques around doing the integration testing. So so that's why one of the reasons why this is my favorite as well, in addition to it being a cool concept. So I really ported this from graph theory and different ways to do testing on graphs, because that's all these services are, is just a graph if you break it down. And the definition of the neighborhood of a service is really the set of services that are one edge away from a given service. And when you think about that, it's really just about the immediate predecessors and the immediate successors of a given service. And so if we have this graph and we take an example here where we use passenger management as the service under test, then what is the neighborhood? Well, the neighborhood, as we said, is everything that is an incoming edge, right? So the API gateway and the passenger web UI, and then anything that's an outgoing edge, in this case, the payment service. And so that would be our neighborhood, which we would want to test. And by isolating that and doing targeted testing on this set of microservices, in other words, everything else is mocked away. And these are the only services that are stood up in your configuration, which is really easy to do, again, with Docker and stuff like that, right? So this is what you would stand up as your integration test, and you would run all your test configurations against that. And the good thing about this is that it helps you to reduce the number of integration test sessions that you need to actually do testing. But on the downside, it can be hard to find where an issue happens if your neighborhood is too big. And so what do I mean by your neighborhood being too big? It means that you might have a component like driver management here in which the neighborhood really is everything except two services. So it's nearly like Big Bang. And this information is both good and bad. It's bad because just using neighborhood testing here is not a good idea, but just applying that concept and seeing, hey, you know what? Driver management seems to be like a really critical and core part of our system. And so maybe we need to put some more redundancy around that. Maybe we need to do more testing around that. And so from that perspective, applying the neighborhood technique here gives you some insight as to the complexity of your system and different components. All right, so again, back to the project, what we do is, and this looks crazy when I look at it, but that's what integration testing should look like, right? Exercising a bunch of things together. What we do is that we use the subdomain as the neighborhood and show practical exercises around that and examples around that, which is a good idea now because now you're saying that each domain or subdomain of your application, we want to make sure that we exercise it adequately. And of course, even within that, you can, isolate certain services and that sort of stuff. And then we also show pairwise integration as part of the project and let you play around with applying that technique. All right, so we kind of walked through our whole stack and talked about, the project and how the project really helps to at least give you an idea of holistic idea of how microservices testing is done from the class level to the integration of classes to then the microservice being the unit to then contract testing to then system integration. And one area of the course that I think has room for improvement or opportunity to expand is around system testing. So while I mentioned system testing and I talk a little bit about performance, for example, performance is an area that is huge for microservices because now you have the problem that each of these services is contributing to your overall performance. What is the budgeting there? How do you look for bottlenecks? How do you get dashboards that you can look at in development and compare them to production dashboards, or do you even want that? And all these decisions around performance testing. And the other big thing in the microservices world, again, where we could probably do some more with courses and getting things done, is the idea of chaos and stress testing. So disrupting and dropping out some nodes and seeing if your system degrades gracefully, combining that with performance testing and doing stress as well as chaos testing at the same time. Those are very interesting things for the microservice community and testing community to attack. And last but not least, is actually first in this list, is that regardless of how you build the system, regardless of how you implement microservices or monolithic or whatever, the end user experience is still going to be really what is critical and what matters, right? And so you can't forget a lot of those things. And so as part of this course, I still also give a brief kind of run through of those things. And then I end off the course talking about the future. A lot of people are interested. I work at test.ai, so a lot of people are interested in the use of AI and machine learning and where it fits into microservices and testing and that sort of stuff. So I also give some of that perspective. And so again, the whole idea here was to give you guys an idea of what the course content is like. And I've done this course as a half-day course, right? Where it is 4 hours long, not as in depth, and I've done it as a whole day, full day course. And I've also done it for organizations where they want to have 2 or 3 days just looking at this stuff, right? So the idea here is that if you guys are interested in having something like this in the whole committed initiative, to let us know, right? Again, happy to engage with you guys in questions. And feel free to add me on LinkedIn. I love talking about these things, these challenges, these problems. And if you're living in the microservices world, we still live in the microservice world. And so feel free to engage. So I'll stop and I'll open it up for questions. Any questions or comments?
Tariq?
Yeah.
My name is Shiva.
Hi, Shiva.
I have an initial question actually to keep motivated, I guess. But the animation character you have used in your presentation, right? Is it possible to know the name of the character?
Oh, Chicken Little, you talking about this guy here?
Yes, that guy. Yes.
His name is Chicken Little. It's
Okay.
from
Okay.
a movie called Chicken Little.
Okay. 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 Thanks for that. It's okay. I want to ask a quick question actually. Okay.
Mm.
With your point of presentation, when you just said good and a bad, right? Okay. There you
Yeah.
have you mentioned that the bad side of it. Okay. You mentioned that
Yeah.
if a microservices is too fine grained, okay, then it could lead to a problem of nanoservices, right?
Yes.
In your good and bad, right? So
Yeah.
how
Right.
how that how that as you as a microservice architecture engineer, how you make sure that your microservices are not too fine grained and it is not too soft at the end as well, because you need to be very narrow in designing that, because you need to follow all the guidelines and protocols while you're designing that, right? So we should make, so there should be criticality in doing so. So how you maintain that that your microservices are within your limitation?
Yeah. So first thing is that depending on your domain is how you start to, and I'll recommend people to either read books on domain-driven design or evolutionary architectures. I can provide references to those. But it's important. I think one of the heuristics that I use for knowing if it is getting too small is referring back to the domain of the problem. In other words, there's when you think about even object-oriented programming, for example, we leverage objects from the real world and model those, and those become part of our solution. We're doing the same thing here with microservices, right? In the real world, in some sort of any kind of system, even the banking application, there's an account. An account exists regardless of if you have a computerized software that does your banking for you, or you're just walking into the bank, there's an account. And that domain itself has a lot of different things as part of it. If you're seeing that your microservice is not mapping to your domain and you can't seem to see that relationship because you've gone now really, really small, and that elements of that domain object are scattered all over the place, then that's one indicator that you're not you're getting into a bad design. I think the other what is probably more easier to recognize is, but it's kind of too late in the game, which is why I prefer to think about the domain up front, is you're having a hard time managing what you have going on, right? Like everything is breaking and there's a lot of these smells and you have too many services and it's becoming harder and harder to debug. Like this paradigm is sometimes painful, but it has a lot of benefits, and I think it's the future of where we go from a software engineering and development standpoint, because I think it enables a lot of um, very dynamic and very beneficial behaviors, but you have to control it in that respect. So if you're seeing that rapidly you're having all these services and you can't seem to manage or maintain them, that could also be an indicator. But you want to have you want to have leading indicators and not trailing indicators for helping you with this stuff. Does that help?
That's really helped to get some understanding on that, because I am a novice to microservices, but I'm looking into enhance my skills into it. But the other question, like, you also said that, initially you had a trouble convincing the organizations or your organization to set up the microservices, right? So how was that tough enough to convince the organization or the team within the organization to implement, and what are the challenges usually you faced at that point of a time, and how did really happened, all the things?
Yeah, I mean, there was a number of things going on there, and it wasn't really that we had trouble convincing them to use the microservices or to go that direction. I think people were not familiar with it, so they were hesitant and in sorts. But eventually, once you learn more about it, you go there. I think the quality side was more hesitant to adopt because they were worried that quality would plummet. And the way that we kind of handled that again was uh, uh, multiple ways, right? Number one, you want to, with any new technology, the first thing or approach or method or technique, you want to start somewhere that is not like critical mass. That if it fails, that everything is going down, or it's kind of like it could be critical, but it is so new that right now you have a bigger room to experiment. So you either want to take a portion of your monolith that you're trying to transition to microservices, if that's what you're doing, that is not uber critical and is a place where you have room. For example, we built HR and payroll software. I wouldn't start transitioning to microservices using the payroll engine, right? Because the payroll engine that pays people, if there's issues there, then that's a problem. But I might take some fringe portion of the system and do it on that. Or if I was building a new system and I had the resources to spin up a new team, well, that's different. They could fail in the beginning, right? We start with that and give them that room. So I always recommend at least, first of all, getting people to know that everything is about managing risks and to identify, where your risks are and, you know, uh, do it accordingly, right? You make your transition accordingly. The other thing that I found was useful was education, right? So number one, I had to learn more about it myself to become comfortable with it. And that also meant educating more and more people about how it works, about the benefits. It meant starting to put together information on testing, which was the beginning of the content for this course, and sharing that with folks. You got to manage their, a lot of times, like it's the emotional side of people that you have to tap into. It is, you know, once you can tap into that emotional side and figure out what is driving their fear, what is driving their emotions that they're hesitant, then you can kind of quell that by just taking, the appropriate steps to bring calmness. Like, hey, it's not gonna blow up. It's not gonna fail like that. Or even if it fails, like we've already made sure it's in this area of the product where we have wiggle room to experiment, and we're gonna take time to figure out quality, and we're gonna do all these things. So that's how I approach that.
Thanks, Tarak. Tariq, sorry. My apologies. I have
Yeah, yeah,
one
no, no,
one
no
last
worries.
question with that.
Sure.
If the panel is happy to ask, I can go ahead with my question.
Yeah, go ahead.
Okay. Tariq, you mentioned with the tool stack, right? You have the list of tool stack which you showed us at the end of this, the last slide, probably the button slide. You mentioned that because like usually with the knowledge towards the Postman and everything, we use the API calls to do
Mhm.
the kind of API kind of validations, right? Uh, uh,
Yeah.
so how that the microservices, the calls are made? Okay, when we design the microservice architecture, right? Okay, so how the calls are different compared to the normal API calls? Because you mentioned here you will be using the rest assured, and also that you showed us like initially you'll be showing some setup of Postman as well, right? So how that is different when you make it calls using microservices?
Yeah. So I can show you. Well, so let me see. This is on the fly stuff. Let me try to pull up the the code here for you, and we can look at it briefly so I can show you what is different. So I got to move this from this screen up to 1 second. All right, and I'll make this bigger. I know you can't see what's on the left, but I'll at least try to make it so that you can see what's on the right a little bit better. So, I mean, at the end of the day, depending on what you're doing, you're still testing and the service via the API, unless you're doing the class level testing. But when you're doing that, like there's just similar things that will look familiar to you, right? Like where you are using the frameworks to invoke, right? So you have some path to your URI. In this case, this is the deposit service or the deposit, path to deposit. And here you're actually using rest assured and, oopsie, sorry. Using rest assured to do things like, create accounts, and then you're posting to this particular URI. So you're building up your test, right? So your whole goal of your test here is to actually invoke the microservice at this level with certain parameters and check the results after you're done, right? So here the action is really to post here. Oopsie, sorry, 1 second. Sorry, this is some decompiler I clicked into decide later. Where was I? Kill it out. So your whole idea is to set up the test to be able to invoke a particular URI with certain values, and then you're going to check the response, right? So you check that the status code is 200, you assert that the values in the JSON field, So it looks similar in that you should understand that when it comes to API tests, you're invoking the API with certain data values, and then you're checking the response for certain status codes or a certain part of the payload happening different things, right? So, and this is just one aspect of the testing, right? There's quite a bit of other types of tests that you'll see in here. These are the event-driven tests that you have, right? Where you have the events that you expect to fire off. From that standpoint, there's ways that we set up the mocks, right? So we have a provider, we have a consumer for our different aspects of your contracts, and then you have your contract being built out here for your contract test. So there's a lot of different, we have our mock repository. So this is how we populate fake data. There's a lot of different parts of this whole thing that you get exposure to throughout the project, even looking at just the configuration environment files, right? So how you, for this particular configuration where we're just mocking externals, we have each service and we have what we're standing up in each configuration. So, and you have each of your YAML files for all your configurations. So the project is, like I said, is pretty involved, where you go through each and every part of a system like this, right? And sometimes that can be overwhelming for some people. But again, like I've taught this course to folks who are not really super technical. And I think the expectation is first to just get an understanding of each piece, and then maybe focus during self-paced learning, go back and focus on, okay, I want to focus just on contract testing, because we could actually have courses. There probably are some courses that will be available on Commit Ed or Committed with, just on contract testing, and you can dig deeper. But this is meant to give you the whole picture, all the different pieces, and then with some detail, and everything is there. And the open source project is meant for you to be able to continue your journey learning, because we didn't learn this stuff in 1 day or a couple hours. Like, this was 3 years of learning, right? So you can expect that, hey, at least I have a starting point. When we started, we didn't have anything like this available, which is why we created it. Does that help?
Thanks, Tariq. Yeah, it's really helped to understand what exactly how the calls are made to the microservices. Thanks for
Yeah,
taking quite amount of your time, and I would like to thank panel also for allowing me to raise my questions. Yeah, that's all from my side. Thank you.
awesome.
Hi, Tariq. So actually, yeah, I had a few questions. I mean, like related to the technical implementation of things you have showed. So maybe I can
Mhm.
directly go on and clubbing those all questions for the so that maybe they can have some common answers also. So if you don't mind.
Sure.
Yeah, yeah. So the first question is like as we have talked about observability, monitoring, and observability things. So there are tools. I mean, like which put some agents in the microservices, like maybe some Datadog or and in cloud we have some Cloud Trail or CloudWatch or which can gather various metrics. But then from a testing perspective or from from basically from the testing perspective, if we want to make sure like our observable our microservice is good in terms of being observable, so do
Mhm.
we have a list of metrics that at least should be visible or should be accessible through I mean like various observability tools? So do we have some kind of do we need to set that kind of expectations? I mean in terms of making sure that our microservice which our developers has developed is a compatible to be termed as observable. So that is my
Gotcha.
first question. Yeah. And
Mm,
then
okay.
yeah. So and then I just wanted to know, because I'm hearing these things a lot, like wire mock and mocking. So is there any kind of a difference of scenarios or situations where you use wire mock specifically and mocking? So this is one. And then and also, like, if we have talked as we have talked about API testing. So obviously, like we if our microservice has some endpoints and all, then obviously like API testing is going to be part of huge part. So does it like assuming that there are APIs, other RESTful APIs, so can we club the API testing, or can we put API testing in the service integration testing layer, or exactly where it falls? I mean, this doing things like using
Yeah.
behavior driven rest assured and all those things. So where does it
Yeah.
actually falls? Like, is it only end to end, or is it service layer? And also, yeah, so that's one thing. Or maybe like, as you have talked about neighborhood testing and pair testing, pair service testing. So how do we leverage API testing in that case? Or is it not compatible to do API testing in those cases, like where neighborhood testing or maybe service integration testing? So that is one thing. And so last question is that for event driven systems, like where it may not be simply request response things, maybe it's like asynchronous things, uh,
Yeah.
where it's so yeah so is that doable using rest assured, or we need to take help of some other things like we do in Python, like maybe async IO and all those stuff? So that is one thing. And finally, I would like to ask, like, if all the things whatever you have uh, tools or in the methodology we have discussed, is it compatible if we transform these things into Python? So maybe like, if any organization, or if my organization is using Python for automation, so is it doable in Python also? And if yes, then irrespective of the language, Python or Java, so any particular design patterns you would suggest or advise, or you yourself adopt? I mean, design patterns known to us, like maybe uh like strategy patterns or all those patterns. Like I'm not too much into it, but just want to know. So these are the few questions I had. So I can repeat if you want me, but yes.
Yeah. I mean, I'll try to answer as many as I remember, and then you can remind me of the rest, right?
Yeah.
But the first one that I remember is you asking about observability
Yes,
and
correct.
from a testing standpoint, where you how do you work that out, right? Because there's observability from the kind of system development and DevOps standpoint, right? Deployment.
Yeah.
But then there's observability that's important for testing. Um, the first thing that I'll say is that observability, when it comes to observability and controllability, as a matter of fact, when it comes to testing, is very important. And the challenge becomes is that there's actually a conflict between what the designer wants from a observability and a controllability standpoint and what the tester wants. Because
Okay.
the designer actually is trying to hide information, right? That's why we talk about information hiding, we talk about encapsulation. All those things are very good design patterns that are not very great for testing, because the reason that you're hiding things away is because you want people to use the interface, meaning the API or the programming interface for the service, or if you're talking about a higher level, you want people to use that interface so that they're not tying whatever they're doing, integration or even testing, to the implementation details. So if I use MongoDB within my service, or if I use, and I want to change it out later to use Postgres, like, it shouldn't matter to you, because you are not getting into that when you're integrating with your system. So from a development standpoint, you want to hide that away so that people don't do that, because if you tie it to that implementation, then when that implementation changes, then you got to go change your other system. So for development and architecture, you want to hide information. For testing, we need to get at that information. It matters what data structures you're using. It matters what database you're using, because we want to test the specifics and the peculiarities around those things. So you're always going to see that conflict. I would say
Yep.
that there's not a laundry list of things that I have that I can tell you that when it comes to your microservices, these are the things, any checklist of things that you want to have. I would say that the heuristic, or uh, the principle that I go by, is that I want to be able to get to the complex areas of the application, especially complex areas of the service, uh, to be able to test them adequately. And if I have a lot of complex logic hidden behind some interface, and it's private and I can't get to it, then I need to somehow either request that we break that encapsulation, right, which is not always the greatest thing to do, or you want to refactor or redesign the system so that it is more testable. So, but you always have a balance between designing for testability and sometimes designing for good development practices like extensibility and stuff like that, and help with testing, but sometimes they don't, and there's going to be a trade-off. You don't want to also go the other route and just expose everything for testing, because then that opens up security issues. So there's
Exactly.
a balance there. There's a balance there that you have to kind of work around, right?
Yep.
So hopefully that helps. Um,
Yep.
on the API testing question, where you asked about um, how this stuff fits in. The API level, if you're testing anything, like all of these things invoke APIs, right? Whether it be on the service, the question becomes whether or not it's a private API that's just local within the system to services and other services, because it's not going to be called from outside, or if it is something that is, because of the gateway, you're actually allowing these things to
So
be called
yeah,
from outside.
maybe internal and
It's,
external APIs, public
yeah,
or private APIs.
exactly. So for
Yeah.
example, if I look here and I think about my gateway that comes in here, I have external calls that are coming here. Those things, to me, I view them as system integration level tests, right? Or even for me, if I'm thinking about microservices testing, if I think about it, anything behind the gateway for me also could feel like a system level test, right? Because I'm not caring about the user right now, right? But I want to exercise my system from end to end, right? So I think of
Yep.
those things kind of end to end if I'm coming from outside. Sorry, if I'm coming from outside here. But within here, there's a lot of stuff that goes on. Every test that we build, every configuration that you saw, you asked about wiremark, which is another question that you asked about. Wiremark and things like that, and even Mockito are for isolating certain aspects of the system. So for example, I might use wire mock to mock out this entire domain, right? Or services that get called through here, right?
Okay.
Or even an individual service within here. The same way that I might use Mockito, if I go inside of a service, there's a class in there that I don't want to call. I might use Mockito to mock that out and just, so what wire mock and stuff will do, it'll stand up the dependencies and it'll allow you to simulate that it sent back things without having this actual thing up and running, right? So
Yep.
any service that's outside that you call, normally, obviously, if it's outside, you're calling it through this gateway and going through this whole process. It allows you to simulate that and pretend that you called the account service and got back the information that you wanted by putting the dummy data there and stuff like that. That's what some of those dummy things were on that site. I think I'm missing one question or two questions. Is there? Do you remember what I didn't? So I talked about observability, the API testing, the wire mock question that you had.
Yeah, I think well, yeah, okay, yeah. So definitely, yes, like I got a very good points, as you have talked about the conflict part and then the WIMOC and this part, and also from the thinking perspective, like when we should think from an integration perspective, or is it a internal service integration perspective, both can be thought of in respect to APIs also. So that is a very good and valid point. Like I got to learn. Also, yeah. So one questions maybe it was related to event-driven systems. I mean, where the responses are asynchronous, or where it cannot may not be always like request response kind of things. Like maybe we will time out eventually. Like if we kind of wait for the response. So in that case, do we need to go with maybe yeah? So my question is like, if it is event-driven systems, then I think going with the API is not the way. I think I don't know, maybe
Yeah,
in that,
so for
yeah.
that, I mean, yeah, you'll see here. You'll see here the event stuff, and then the other question you had was the Python migration. So I remember there.
Yeah.
The eventing stuff is again, you can pull down the project and you'll see examples here of how you can kind of do that. There's not much information out there on testing eventing. There's some, right? But you might
Yeah.
have to dig deep to find it. But I give examples of how you use the Axon framework and to just check, right? It's all about making sure that the correct events are being emitted and being picked up, right? Because it's kind of like loose coupling instead of calling, right? So now you're not,
Yeah.
API testing, you're calling the API directly. Here, you're just emitting an event and someone else is watching and picking up that event. And so to test that is a little bit
Yeah.
different, but you have examples in here for how
Maybe we
that's
can
done.
test the queues, maybe in AWS terms, if I speak, like, we can
Yes, you can
always
test the
test the
queues.
SQS and all those things.
Yeah, you kind of split it up and do kind of separate isolated testing that you're emitting the right events and then that they're being picked up. And then you should still have some end-to-end stuff that, and then performance becomes the issue there because then you could be missing events. So there's lots of stuff involved in that,
Yes, yes.
but you'll get that. On the Python stuff, in terms of like porting certain aspects of this to Python, I don't see why not. There might be, depending on the framework that you're using, things could be different. But again, we have, there's different paths that you can go along, right? Now, the cool thing about this is that it may not matter, like it really should not matter as much
Yeah.
technology, unless that you're trying to keep your team confined to certain technologies, right? And you don't want to get too many technologies in play. But if you reach out to me and let me know kind of like what you're thinking, I can share with you what are some of the other possibilities that might work. There's also wrappers and stuff that you can wrap around. I was just looking at
Yes.
someone asking in one of the forums today about what was I think it was used to be called Jython, which is just Java to Python wrapper.
Okay.
And so there's other things that you can probably do, but what would be the best thing really depends on your use case. So
Yeah.
Feel free to add me on social media or wherever, or reach out to me through.
Yeah. I can see you in the LinkedIn. Actually, we have a
Okay,
connection.
cool.
Yeah. Yeah.
Okay,
So
awesome.
so yes, definitely. Like, it's been glad that you took that effort to answer all these questions. I really appreciate it. And any plan, like, to include testing around the kind of a newer domains like serverless and all those things, which is coming, in my organization also, like, all of my, I mean,
Yeah,
typically these days what happening is the microservices are being deployed as kind of a lambdas into
yeah,
AWS.
sure.
So any
Yeah,
kind of
yeah,
a
yeah.
plan you have to include that sort of testing also? I mean, because
Yeah, I
that is
mean,
very
these
new.
things,
Yeah.
yeah, these things are always evolving. Actually, like you'll see, like this course already has gone through several iterations, and I keep adding
Okay.
stuff. Serverless is an interesting thing too, and I thought, again, it just depends on how much time and how big and where the demand is and stuff like that. So,
Yeah.
like I mentioned here, like if these are things that you guys are interested in, I know that this is a new platform for testers, but please let them know what you would be interested in seeing so that they know. If they don't think that there's an interest, then it might not make its way in. But I don't see a lot of courses on stuff like this, especially when it comes to
Yes.
testing. But
Exactly.
testing serverless and testing microservices and bringing that into this world, like I said, there's a lot of room and a lot of expansion. So it depends on the demand. I'm happy to engage with anyone in the community, like I said.
Sure.
So feel free to reach out and talk about that. But I would love, the way that this thing evolves is by, when I teach these courses to different folks and I go through that process, um, I usually get ideas or people usually share and contribute, and that's how it becomes better. So that's definitely
Correct.
uh, one way that we can get those things done is by
Yeah.
working together and everyone sharing their experiences and stuff like that.
Yeah. So what is the next step? Like, if as an individual, if I want to pursue your training, so is it happen? Does it happen is in group? I mean, this particular training. I mean, this was a teaser. Basically, the main training.
Yeah.
Do you give individual trainings, or is it always at the group level, or how does it goes?
Yeah.
I mean, where can I
So
find the details
so
about?
yeah, you can just reach out to me and I can tell you. I normally do this kind of training, I either in a conference setting or online learning environment like this one, the committed stuff. So if you want to see it there, that's one thing. I also do it sometimes for private companies who might want a small team of people. Like normally it's not one-on-one. It's normally like the last one I did, for example, had a team of probably like 8 to 10 people that I gave the training to, and went into the details of all this, right? And we did it over like two days, right?
Yep.
So it all depends, right? Again, I know like the whole initiative here is to get more learning into this online system. So
Yeah,
please
you
feel
can
free to.
definitely create, like kind of a very lighter version for individuals like us, and then
Yeah, 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 yeah.
get some subscription kind of things. So
Yeah,
that
yeah,
will
I
be
think that's the whole point of this thing, right? Where then we maybe break it up into chunks and make it self-paced learning. A lot of that takes time and effort on my
yes,
side,
yeah,
but I think it would still be good, right? Because then I know people are wanting to do it on their own time, right? Like I mean, you have a lot of time sometimes now in the new state of the world, um, but like yeah, people want to be self-paced and kind of go on and learn it themselves, and having it kind of recorded and on demand is a useful thing. So again, let the feedback come
yes,
to
sure, sure.
Victor and the folks that are doing that, and voice your wants, right? So
Yep.
cool.
Thanks for the answers.
You're welcome.
Yep.
All right. So I think we're just about out of time. At least I know I have another meeting at 1:30, so I'm gonna have to run my time. But this was a pleasure. Like I said, everyone feel free to add me on LinkedIn or Twitter or wherever you feel most comfortable, or send me an email. But this was awesome. All
Thanks,
right.
Tariq. Yep.
All right. Take care. Bye
Yep.
bye.
Bye bye. Yeah.